today we're going to start with kind of picking up where we left off, file works, but we're going to have a new topic called binary files. Okay. The binary files, I have some notes here, but the rule is a binary file takes less conversions than a text file. And binary files are written in raw data. A lot of times, depending on the language, you can sort of read a little bit what's there, but not everything that's there. So it's data that it's not necessarily ASCII, but you might see a smiley faces part. If you tried to open the file up, even though it's no longer a text file, you might be able to see some things, but not really. I remember way back when I was teaching high school and Bard's Tale was out, and we had a piece of software called Zip Zap, and you were able to look at the files as binary. And my students figured out in the game where your money was. So they went and actually altered it using the Zip Zap. So then all of a sudden they had an infinite amount of money and they could buy weapons, and they just cruised right through the rest of the game. But yeah, a lot of times you can't understand what this raw data is. So looking at binary files, we're going to start with how do we open them? And we're picking up right where we left off with this IF or this F stream. And when I get ready to open a file, you notice that I not only say to open it up for output, but I also want to write it as a binary file. So again, that it'll have less work to, excuse me, sorry about that. So it'll have less to do as far as the conversions with the binary as it would with the text file. All right, so some important things to know about trying to write as a binary file. Everything needs to be a character. That sounds kind of weird, but we need everything to be a character so that it can use its ASCII type number. So it can work with this. It's not necessarily stored as ASCII, but it's similar to that. So when I get ready to write, it'll be really easy for us to work with a file of characters. Okay, so when I get ready to write it, I'm going to write, and here this guy needs to be either the address of a character or a pointer, as I mentioned in my comment, and then the size of it, which we're going to see later where this becomes important because it's going to be the size of something other than just a character. Okay, so this size of method was brought up to you way back some point, never really used it, but now it's finally becoming something that's necessary. Here's an example, file write data. Data just happens to be a pointer to an array of characters. And I want to write the entire array of characters. So I say size of that address where all of everything is, where all of the data stored in the array is. Okay. And again, I have this, I keep writing it. It's all about everything being characters. So you had some code listings and what's wrong with my book? It doesn't like me. And code listing 1213, if I can get to it here. Code listing 1213 starts out with, we have our traditional header files, include iOS stream, include F stream, and the F stream file. Okay, and then we come over here and we get ready. We're going to open the file, just like I mentioned a moment ago, and we're going to write data. And again, data is an array. So what's the size of my array is what it needs to know. So if I come down here, if I have an array of 4 characters, what's the size of it? Your answer will rhyme with great, but it's a number. It's not 7.
8 bytes.
8, yeah. So this guy would generate the number of 8 bytes. Okay, so size of data. So I come in and I'm writing all of that over as an entire array. I now get ready to read it in. You notice I'm reading it in as a binary file. Okay, I get ready and read. How much do I want to read? So I have this. Again, I'm reading in the entire array. What if it's a text file? I'd want to have a loop and read in a character at a time. This guy's just going through the array. And as you can see, I can display the data as I need. Okay, you had code listing 1214 to type in. This time, I have an array of numbers. Now, remember I said, when I write to this binary file, it needs to be a character. And this time, I know the size of this array is going to be how big? $20. I hear 20. Characters are of size 2. What's an integer size?
Would it be 40?
Yeah, integer is going to be 4 bytes. So 10 times 4 would in fact be 40 bytes. So when it does this size of it, knows to write 40 bytes. Now, I want to get ready. I want to write it output to the file in binary. And you notice when I want to write that entire array, I don't know why he jumps right in with arrays instead of just doing single characters and single numbers. But this time I have to do this reinterpret cast as a char everything inside of my array of numbers. Just a syntax that you have to know to put in there. Close the file. Down below, I'm doing the exact same thing when I get ready to read. I have to reinterpret it. And then I'm going to be able to display everything at that point. Questions? All right, sounds pretty good. Okay, and as we just mentioned, we have the whole writing data other than chars. We just looked at an example, and I think we should be good to go with that. Code listing 1215. This time I'm writing a struct. Okay, I'm writing several structs. I'm reading in all of the information. Up above, I have a struct declared. It's called info. When I come down here, I want to write that struct. So I have the address of the struct. Remember a moment ago, we had the arrays, and an array name is the address. That's why I said earlier, we're going to be using either addresses or pointers. Okay, but the name of the array is the same as a pointer. So I'm going to do the reinterpret cast again to turn it into characters, and then size of person. Again, person would be this big thing, and or I don't know that we need to count all these up, but what's name 51 times 2 plus another 4 plus another yada 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 yada. Whole lot of characters. So luckily it's doing the size for us, and we do not have to do the size. Questions? You think you got it? Yes or no? Bueller?
Yes.
Yes. Thank you. I got a yes. All right. So what we're going to do today, it's kind of simple, and you can tell we're starting to wind down the semester. I have an encryption program on D2L. I want you to read it in. It's a file of characters. I want you to display the message. And when you get it, give me a call.